Hello, welcome to a video on rearranging equations. I think it's a really important topic. It kind of comes up a lot in GCSE in a load of different questions, and it definitely comes up a lot in A-level as well. And it's something in my teaching I've seen a lot of students kind of struggle to get their heads around a little bit, and that can make it a bit difficult. So there's a few key points that I wanted to talk about before I showed you some examples. And I think if you can remember these key bits and you kind of have a good grasp of them, that really does help you out. So the first thing is, all we're basically doing is doing the opposite, and we're just going to do the opposite to things to move it. So if you can remember, to move something, so to times, if something's times at the moment, then you want to divide to move it. If something is divided, then you're going to times to get rid of it. That kind of idea really helps you out. The next thing is that the order you move things does matter. The order matters. And you'll see that in a few questions that we do in a second. If we don't pay attention to the order that we're moving things around in, that can make it a bit tricky as well. And then the kind of the wording of the question can be a bit weird, and if it says make something the subject, so let's say make x the subject, that just means get x on its own, so get x equals. So if it says make y the subject, you've got to get y on its own. If it says make x the subject, you've got to get x on its own. Okay, so let's look at our first example. So e(g)(1). And let's go with equation or a formula you might recognize. V equals 4/3 pi r cubed. So it's the equation for the volume of a sphere. So if the question said something like make r the subject, or get r on its own, or however it wants to word it, we just need to rearrange this equation. And this is what I mean by the order mattering. And the way I think about it, I mean, I don't think about it now, I've done enough of them, but once you to start you off, if we start with r, that's the bit we want to get on its own. So if we start with r and think about the order that you would work with r, well, the first thing you do with r is cube it. Because of bid mass, you do the indices first, so you'd cube it, then you times by pi, then you times by 4/3. So to do the opposite of that, we basically just need to do the reverse. So the last thing that we would do was times by 4/3 pi. So the first thing we're going to do is divide by 4/3. Okay, so if we do that, we would get v divided by 4/3. Now you might think that's not particularly nice, and it isn't, but actually for this kind of question it doesn't really matter. We can leave that as it is, that's okay. So we've got rid of the 4/3, so we'll just get pi r cubed. Okay, so the next thing we said is that after so the last thing we had to do was divide times by 4/3, so the next thing is to divide by pi. So that's our next step, we divide by pi. And if you do that, we get the volume divided by 4/3 pi is equal to r cubed. That's an equal sign, it's just filled it in a bit. Okay, and then the final bit, which was the first thing we would have done to r, which is the last thing we're going to do when rearranging, is to get rid of this cubed. And the opposite of cubing is to cube root. So we're going to cube root both sides. Now again, it's not particularly neat, but that's okay. It's going to be, so I don't know why I've changed that to, I don't know where I got 4 from, sorry, that should be v. Hopefully you spotted that earlier. I guess I was talking about 4. So that bit there should be a v. There we go. So it's going to be v over 4/3 pi is equal to the radius, like that. And that's all you have to do. We don't need to try and simplify this or figure out what it is. All we've done is just undo all of the bits that we would have done to r to get us back to our answer. Okay, so just to kind of recap, we started thinking, well, if I had r, I would cube it, then times by pi, then times by 4/3. And we just do the opposite in reverse. So divide by 4/3, divide by pi, and then divide, cube root, because that's the opposite of cubing something. And that gave us the cube root of v over 4/3 pi is equal to r. And that's it. Okay, let's look at another one. So e.g. 2. For this one, we're going to go with the square root of x minus 4 divided by 3 is equal to 4y, and we're going to make x the subject. Okay, so remember that just means we want x on its own. So again, think about, well, if I started with x, what would I have to do? Well, you'd have to minus 4, divide by 3, and then square root your answer. So we're going to do the reverse. What's the opposite of square rooting? Well, the opposite to square root something is to square. So what we're going to do is we're just going to square both sides. So that will give us, well, we're going to get rid of the square root. So x minus 4 over 3, and then squared, so this bit is going to become 4y squared, like that. And the reason I've done it in brackets is it's not 4y squared with just the y squared, it's the whole thing squared. Okay, and I mean I could make that 16y squared, I could leave it, it doesn't actually matter when we're rearranging equations unless they ask for it in a particular form. So I think I'll make it 16y squared. So x minus 4 over 3 equals 16y squared. Hopefully happy with why that's 16, it's because the whole thing is squared, like I said before, so it's 4y times 4y, which is 16y squared. Okay, so back to our left-hand side. The next thing we need to get rid of is the divide by 3, and the opposite of dividing something by 3 is to times by 3. So that will give us x minus 4. And if you think, well, there's a reason I haven't times the top by 3, sorry, it's because I was dividing by 3, now I'm timesing by 3, so that will cancel out, just leave me with x minus 4. And on this side, we're going to get 16 times 3, which is 48 y squared, like that. And then the last thing, to get x on its own, we just need to add 4. So we plus 4, that will give us x equals 48 y squared plus 4. And then we're done, because we've got x on its own. Remember, that's what we're aiming for. We're aiming for x equals, because it said it'd make x the subject. That's what we've got, so we're finished. Okay, so again, just to recap, this one we had to get rid of the square root first, so we squared, which it's better to do that in brackets so you don't forget to do the 4 squared, and that gave us that. And then we times by 3 to get rid of the divide by 3, and then we added 4. Okay, and that gave us that. So EG3, this time we're going to do a minus 3 over a plus 2 equals b. And for this one, we're going to make a the subject. Okay. Now, it might not be obvious at this point, but this one is going to be a bit more tricky because we're going to end up with 2 lots of a. So it's not as easy as the other ones, but the first thing I would think of is, well, what's the bit of this question that's not very nice? And to me, the bit that I don't like is this bit at the bottom, this fraction. So what I would do is think, well, how do I get rid of that fraction? What's the easiest way to get rid of the divide by a plus 2? And so we just need to times by a plus 2. So that'll get rid of that fraction at the bottom. So let's do that. Let's multiply by a plus 2 to get rid of the fraction at the bottom there. So that'll give us a minus 3 equals b times a plus 2. So already that's a bit nicer, I think. We got rid of the fraction, we got rid of the a at the bottom, and a over a is not that nice. So this is a bit nicer. So next thing is just going to be to expand that bracket out. That'll be a minus 3 equals b times a is ba, and then plus 2b. Okay, so we got rid of the fraction at the bottom, nice, and we're trying to make a the subject, and always kind of keep that in the back of your mind. So if we're trying to make a the subject, the kind of trick here where there's 2 a's is to just get all the a's onto the same side, and then hopefully we'll be able to do something from there. So I'm going to minus ba to get this ba to that side. So that'll give us a minus 3 minus ba equals 2b. And then after that, well, I don't really want this 3 here because that hasn't got any a's with it. So I'm going to add 3. So that'll give me a minus b, a equals 2b plus 3. Just moving the minus 3 to that side. Now this is the trick with this. Well, we've got 2 a's and it almost seems like, well, we can't just get 1 a on its own here. And the trick is to factorize, to take out this this factor of a, because a goes into both parts. So if you take out a factor of a, so divide these parts by a, you get 1. A divided by a is 1. And from this one, divided by a, you just get b. And so we've kind of reduced the problem from having an a on both in both parts, just having an a times by that. And then the final bit, and this catches people out a little bit as well, is, well, how do I get a on its own? Well, at the moment we've got a times this bracket, so we're just going to divide by the whole bracket. So we'll just divide by 1 minus b. And that will end up with a equals 2b plus 3 over 1 minus b. And there you go, we've managed to get a the subject. And yeah, and that's pretty much all there is to it. I mean, there are some tougher questions out there. I think that example 3 where you need to factorize is one definitely to bear in mind, and that does come up reasonably often when it can be tricky to spot that you need to factorize it, but hopefully it helps to see that one. And just to kind of reiterate those key points, we're always just doing the opposite to move things around. As long as you remember that, you'll probably be all right. And the order does matter, so make sure you, kind of like we did in the first 2 examples, figure out, well, what do I need to do first and how do I need to kind of go about undoing what I've done. And just remember that key word, if it says make x the subject, that just means get x equals. Okay, hopefully that helps. Thanks.